So I'm going to be going over electromagnetic waves, and this is for Unit 3, Syllabus 11 through 14. So the picture on this slide is of the electromagnetic spectrum, which I'm going to be getting into more later. So for number 11, I'm going to be talking about electromagnetic waves. And so electromagnetic waves are a form of energy that have wave-like behavior. And this is going to be controlled by electricity and magnetism. So this is going to include any wave on the electromagnetic spectrum. And it's also important to know that magnetism is going to move the wave up and down, while electricity moves the wave side to side. So for number 12, this is the electromagnetic spectrum, and all forms of EM radiation differ in wavelength and frequency. So this spectrum is essentially showing these differences and which have which. So it's important to know about when wavelength and frequency are going to increase and decrease on the spectrum. So for wavelength, the closer you get to radio waves is that's when the wavelength is going to increase. Frequency is opposite because the farther away you get from radio waves is when it's going to increase. So the closer you get to gamma rays is when it's going to increase. And then for the visible spectrum, this is going to be measured in nanometers. All right, number 13, line atomic emission spectrum. So the line spectrum is a spectrum that contains only certain colors or wavelengths. It's an atomic fingerprint, and samples of all elements emit light when they're vaporized. So essentially what this is doing is it's showing what types of light are emitted from the element you're sampling. And like I said earlier, this is going to be measured in nanometers for your wavelength. All right, number 14. There are 4 characteristics of electromagnetic waves. There's amplitude, wavelength, frequency, and speed of light. So it's also important to make sure that you are memorizing those symbols. That way you don't mix them up. So for amplitude, it is the height of the wave measured, and this is in centimeters or meters, from origin to crest. So on the, you can see that on the diagram I made. And you can see all of these on there. And then for wavelength, this is the distance between 2 successive crests or troughs of the wave. And then frequency is the number of waves that pass a given point in a specific time. And this is going to be measured in waves per second. For the speed of light, this is speed at which light waves travel in a vacuum. So here are some practice questions. You can pause the video to answer them really quick, and then when you unpause, I will show the answers. So these 3 questions are, does wavelength increase or decrease as it gets closer to radio waves? What are electromagnetic waves controlled by? Is visible light measured in meters or nanometers? So I'll let you pause the video and unpause when you're ready to answer. So here are the answers. So wavelength increases as it gets closer to radio waves. And electromagnetic waves are controlled by electricity and magnetism. And then visible light is going to be measured in nanometers. So here's another practice, and that's making sure you know how to label the electromagnetic wave with the 4 different characteristics. So this is why it's also important to know their symbols along with their names. So you can just pause the video and figure it out, and then when you're ready, unpause the video and I'll show you the answers. So here are the answers. We have wavelength, amplitude, frequency, and speed of light. So hopefully you got that right. And that is going to be it for Unit 3, the electromagnetic spectrum and wavelengths.